start sharing the screen.
Okay.
I hope I have kept my. Yeah, it's open. You will have to tell me exactly where we stopped last time.
Last time, uncle. 1 minute, I'll check with
You
my
do
textbook.
example 9.1.
1 minute, uncle. I'll check with my textbook. Page number, uncle.
Okay. We took the steps to solve that we did, but did we finish example 9.1 or we finished 9.2? Which one we finished?
We finished 1 and 2, uncle.
9.2 also we finished.
Yeah, uncle. 9.3 we have to do.
9.3 we have to do. Okay.
Yeah.
Okay. Now that means we have to do assumed mean. Okay. Let us start here. When deviations are taken from an assumed mean, that method we have to do. First method we did was straightforward method. Sigma xy divided by root of sigma x squared into root of sigma y squared. Okay, that method we did, where x is equal to xi minus x bar, sigma xi minus x bar, y is equal to sigma yi minus y bar. Okay, first method. Okay, that is what we did. You remember that? I'll just refresh that. Okay, sigma xy divided by sigma x squared into sigma y squared, root into root. Okay, this was the coefficient of correlation. Okay, where x was equal to sigma xi minus x bar. Okay, and y was equal to sigma yi minus y bar. Okay, that's all. That one we finished off. Then we did a small one. When the data is very small, we did another method. Okay, that method was n into sigma xy minus sigma x into sigma y divided by n into sigma x squared minus sigma x the whole squared, the whole root into n into sigma y squared minus sigma y the whole squared. Okay, again this also whole root. Okay, this problem we did. Okay, so both these things are over. Now we have to do assumed mean method. Assumed mean method, when will you use? See the previous problem. If you see the previous problems very carefully, what was the mean that you got? Okay, you don't have to find mean at all in the second method, so forget that. In the first method, what is the mean that you got? 19. See, y assumed, I mean x bar is equal to 19 here. How much? 162 divided by 9 is equal to 19. So you got a whole number, integer. If you get integer, then you are doing yi minus y bar is becoming easy. Calculations will be easy. So you'll get whole numbers, minus 9, minus 7. You can multiply that and you get 81, 49, all of that. Very easy calculation. Now, if you don't get integer, then you have a problem. You cannot use the direct mean method. Okay, you have to use assumed mean method. That is why we have the assumed mean method. Okay, so when actual means are in fractions, say actual mean of x and y series 20.167, suppose that is a mean, then you should not use the direct mean method. You should use the assumed mean method. Okay, what is the formula for assumed mean method? Very simple. Okay, wherever you used n into sigma xy minus sigma x by sigma x into sigma y, wherever you used x and y, now use dx and dy. Wherever you used x and y, now you use dx and dy. Okay, that means dx is nothing but xi minus assumed mean, and dy is nothing but yi minus assumed mean b. Okay, two sets of data, no, always correlation coefficient. So wherever you are saying correlation coefficient, we are talking about two sets of data. So first set of data is xi, x1, x2, x3, assumed mean is a. Second set of data is y1, y2, y3 and all, assumed mean is b. Okay, dx equal to xi minus a and dy is equal to yi minus b. Okay, b is the assumed mean for the data set b. Okay, once you understand this formula becomes very easy. N into dx dy minus dx into dy. That will be the numerator. Okay, very simple. What will be the numerator? That is the numerator. What will be the denominator? Same way. Denominator denominator will be n into, okay, first thing sigma x squared we had. Here sigma dx squared we have minus dx the whole squared. This will be whole root into again n into sigma dy squared minus dy the whole squared. Okay, see the same thing. Sigma n into sigma dx squared minus dx the whole squared, n into sigma dy squared minus dy the whole squared. Same thing. Okay, for x and then for y. Okay, everything is the same. So that is a formula. So this formula you'll have to remember. Very little time you have to spend, understand the pattern and then memorize the formula. Simply don't mug the formula. It is useless because there is a pattern in the formula. Okay, top one dx dy, n into dx dy minus dx into dy. Like that it is coming. Okay, very simple numerator. Denominator also dx squared minus dx the whole squared, n into dy squared, sigma dy squared minus dy the whole squared. Okay, that is the whole thing. Everything is got sigma. Okay, nothing is a simple one answer. So now, what are the steps now? If this is the formula, what are the steps now? Steps very easy. What you have to find out? First, you find out, take an assumed mean. Okay, first you take an assumed mean. First, okay, put all the x data 1, 2, 3, everything you put. Then take an assumed mean a for x data. Then d of I is equal to xi minus a. That column you fill, d of I you fill. Okay. Once you fill d of I, okay, you can fill d of I squared. D of I squared will be next column you can fill. Same way, one y is equal to 5, 6, 7, like that. No, that also you can fill. Now y, then d of y is equal to, take an assumed mean b this time, which is equal, which is something in the middle of the set y. Okay, 5, 6, 7 means you take b is equal to 6. 1, 2, 3 means you take a is equal to 2 assumed mean. Understand? Okay. 1, 2, 3, middle of a, middle of that set of x, you take 2 assumed mean for that. Middle of set second set y, you take 6 assumed mean b is equal to 6. Okay, dy is equal to, then what? Dy is equal to y of I minus b. D of y is equal to d of y. Okay, then what you do? You take sigma dy, you can take, then sigma dx you can take, then sigma dx I squared you can calculate, then sigma d of y squared you can calculate, sigma you can calculate. Only one thing is left off. What is left off? Sigma of, what you have to do? D of x into d of y. Okay, so that column you have to calculate. This is d of x column. Whatever, suppose you get value 5 here. D of y column you get 6 here. Then 5 into 6 you have to put into sigma d of x into, this is 30 you have to put. Okay, like that. This is the way you have to do. If you do one single problem, you will understand everything, that this is only a procedure. This whole thing is procedure. There is nothing to think. Okay, simply blindly you have to follow the procedure. There is nothing to think. So it's steps to solve the problem. Take the deviations of x series from an assumed mean. This assumed mean should be a. Okay, what is this assumed mean? This assumed mean is a. Deviations of x series. So d of x is equal to x of minus a. That one you are doing there. Same way, take deviations of y series. So d of y deviation is equal to y
D
of
of
y
y.
minus b. This one is
Okay.
that step. Okay. Square dx and obtain sigma dx squared. Okay, every dx, okay, you You keep squaring dx squared. Then finally you add dx squared plus dx, all that you put sum, you will get sigma dx squared. Same way square dy. Okay. Then at the end of it, like here, no, at the last column, get sigma dy squared. Then what you have to do, multiply dx and dy. Okay, that is a separate column is given here. See, dx into dy. That also now finally you add up everything, you get sigma dx into dy. Once you get all this, all you have to do is substitute in the formula, you will get the answer. That's all.
Okay.
Very simple. Okay. What you will do mistake is in the calculation. Very minute calculation you are doing every time. There you should be very careful. That's all. Otherwise, there is nothing to this correlation coefficient. Very simple sums.
Yeah.
Okay. Very simple sums. Long sums, lots of calculation will come. Very small calculation. Plus minus 2, 3, 4, like that only you will get. Okay.
So I just have to remember the formula.
Just to remember the formula. Formula also, you see the pattern and remember. That's why I'm saying. See, this pattern is the same as this pattern. N. For in 10th standard, you get sigma x of I divided by n you will get. Okay, that is for standard deviation. For regression analysis, you will never get n as a denominator. Okay, you will always get n as a numerator. Okay, sigma x of I squared minus sigma x of I the whole square. Like that you will get. The same way n into sigma y of I the squared minus sigma y the whole square. Like that. That is a numerator. Okay. So this one square root, this one square root. That's all. Multiply both the square roots. That is all denominator. Numerator very simple. Sigma dx dy initially, then separately dx, separately dy, sigma minus. Every time n will come in the front. Okay. Only for the first expression n is coming. See, everywhere only for the first expression n is coming. N is not coming for the second expression. Once you remember all that, this formula becomes very easy to remember. Okay. Initially it looks no, it is not big at all. It's very simple formula. Okay.
Okay. Yeah.
Now let us do one sum. Then you will see why this is such a simple sum. Only 5th standard, 6th standard students can solve this problem. There is nothing about 11th standard level that you have to fight to solve this problem. Okay. Now this is a very famous thing, the correlation coefficient between the father's heights and the son's height. Like that. Next problem we'll do. First, let us do example 9.3. Find out the coefficient of correlation. Let us do it in the wait. We will do it in the our own whiteboard. Then only it will be clear. Let us do it in the whiteboard.
Yeah. Okay.
Otherwise, you may not understand. Okay. What is the sum? Sum is very clear.
9.4 now, uncle.
9.3 example.
9.3.
9.3. I'll put.
Sure, okay.
Example 9.3. Okay. Height of the father, height of the son. Very, very famous thing. Okay. Height of the father is x data. It is 65. Then it is 66. Then 67. Another 67. 68. 69. 71. 73. Okay, n is how much? 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. Okay. Now you don't have to find out sigma x and all. So you not bother about that. And now you have to assume the mean A for this data. 65, 66, 67. What? Let us assume 67. Okay. You can assume 68 also. We'll assume 67. Okay. Now what you have to do? D of x I is equal to x minus a. Okay. That one you have to now find out. 65 minus 67 minus 2. 66 minus 67 minus 1. 67 minus 67 0. Again 0. 68 1. 69 2. 71 4. 73 minus 67 68 69 77 6. Okay. Now what you have to find? Sigma d of x you have to find. 6 plus 4 10. 10 plus 2 12 13. Okay, this is 13. Then minus is minus 3. 13 minus 3 is 10. Okay, so very simple. Sigma d of x is 10. Okay, now what you have to do? D of x I squared you have to find. Okay, minus 2 into minus 2 4 1 0 0 1 4 4 into 4 16 6 into 6 36. Now sigma dx squared you have to find. Okay, what is this? 6 plus 6 12. 12 plus 4 16 17 18 19 20 21 23. So got 23. 2 plus 1 3 3 plus 3 6 63. So d of x squared is equal to 63. Some mistake is there. Six plus 6 12. 12 plus 4 16 17 18 19 20 21 22. Sorry, 22. Okay, 62. Okay, very good. Now you got that d of x squared. Now what you have to do, you take y. Y is the sun. This is all father height. This is now sun height. Y values you put 67, 68, what else? 64, again 68, then 72, then 70, then 69, then 70. You should not arrange in ascending order because the correlation pair will become disrupted. Okay, so don't arrange, just put it as it is. Okay, now you get one assumed mean for this one. 1 2 3 4 1 2 3 4, either 68 or 72 we can take assumed mean. Okay, let us take 68 as assumed mean. Now d of y is equal to x minus b. Okay, x minus b. What do you have to do? 67 minus 68 minus 1. 68 minus 68 0. 64 minus 68 minus 4. 68 minus 68 0. 72 minus 68 4 minus 2 here. 69 minus 68 plus 1. 70 plus 2. So sigma dy now you have to get is equal to this is 3 minus
Uncle,
2.
okay, for 70 you have written minus 2. For 70.
70 minus 68. Oh, plus 2.
Minus 2 plus 2, yeah.
You're correct, boss. Oh, very good, very good. They started this interior fellow, the first floor, they started their nonsense. Okay. So this means plus 5. Very good. Plus 5 is there. This is minus 5 is there. Dy. Minus 5. This is plus 4. Plus 5 plus 9. Totally plus 9. Correct? 9 minus 5, 4. So you got 4. 9 minus 5, you got 4. Now you have to put dy squared. How you put dy squared? Minus 1 into minus 1 plus 1, 0, 16. Again 0, 16, 2 into 2, 4, 1, 4. Okay. So sigma dy squared now you have to find out. 4 plus 1, 5 plus 4, 9. 9 plus 16, 25. 25 plus 16, 25, 35, 41, 42 you get. 42. Dy squared is equal to 42. Now one last thing what you have to do, dx into dy we'll have to find. sigma dx dy also you have to find. Okay, so this is dx, this is dy. So minus 2 into minus 1 is plus 2. Same way 1 into 0 is 0. 0 into anything is 0. Again 0 into something is 0. Okay, then 1 into um, what is this? 1, 2, 3, 4 is done. Fifth one. What is the fifth one here? 1, 2, 3, 4, 5. 4. 1 into 4 is 4. 2 into 2 again 4. Then 1 into 4 again 4. Okay, then 2 into 6, that is 12. Now you add this up. 12 plus 4 plus 4, 20 plus 4, 24. 24 plus 2 is 26. Okay, sigma dx dy is 26. Now you got everything you want. All you have to do is now substitute in the formula. What is the formula? N into sigma dx dy minus sigma dx into sigma dy divided by root of n into sigma dx squared minus sigma dx the whole squared into n into sigma dy squared minus sigma dy the whole squared. Okay, that is a formula. What is n? What is n? Hello, James.
Sorry, I was on mute. 8, uncle.
What is n?
8, 8, 8.
8. 8 into dx dy sigma how much?
4.
Dx dy, yeah, this one.
26.
26. Okay. 8 into 26 minus sigma dx. What is sigma dx?
10.
10. 10 into what is sigma dy?
4.
10 into 4. See, very simple thing. Again, n is 8. Root of what? Dx squared, how much?
62.
62. Minus sigma dx, how much?
Sigma dx 10.
10 squared. Into another square root of, this time n again, 8 into what? Sigma
4.
dy squared.
4 square.
How much?
42.
42. Minus sigma dy the whole square. Dy is 4.
4. Yeah.
4 square. That's all you have to do now. Okay. Wait, we will take this put a printout first for you. Okay, let's go back now. Okay, now what you have to do? 8 into 26, use your calculator, how much?
8 into 26. 1 minute, uncle.
200.
1 minute, uncle. I'm taking my calculator.
Okay, okay.
8 into 26 is 208.
10 into 4, 40. Okay. 8 into 62?
496.
496 minus 10 squared is how much?
100, no, uncle.
Don't calculate, tell me.
100.
8 into 42, calculate.
336.
Very good. 4 squared is 16.
16.
Okay, 208 minus 40 is 168. Divided by 396 into 336 minus 16 is 320. That's all. Now you give the answer. Find the answer. 168 divided by, multiply 396 into 320.
Uh, 396 into 320, no, uncle. It is 1,26,720.
Okay, find the root of 1,26,730.
355.97.
55.98.
97.
Okay.
98, yeah.
So you divide that now. What to do?
168. 0.47, uncle.
Okay, I think 2 is coming. You can give after 3 digits. So this is the correlation coefficient. Okay, very simple. What is difficult in this? Nothing difficult. No brain racking. No trying to find what when. Nothing like that. Okay, only remember the formula and do all the small calculations one after the another correctly. Any small calculation you miss, then the whole problem will go for a toss. You understand? So be very careful with your calculation. There I told you, I put 1 minus 4, you said that is plus 4. No, like that only you will get mistakes and the sum will go wrong.
Yeah.
Okay, avoid those kind of mistakes. Then you are really got the 10 out of 10 for this. Okay, very easy sum. No brain racking your brain, nothing. Everything calculator will do. Okay. Okay. Now that example we have solved, let us do some smaller sums. That means heights of the fathers and respect to sons are positively correlated. If the height increases of father, the son's height increases. If the height decreases, then the height decreases. Okay, like that. So that is a positive correlation. Now let us do example 9.4. Okay, let us do example 9.4. Following data is given. N is equal to 9. Sigma x is equal to 45. Okay, then sigma y is equal to 108. Sigma x squared equal to 285. Sigma y squared equal to 1356. Then sigma xy is equal to 597. Find R. Okay, find R. Directly you can substitute in the formula. Correct? Directly you can substitute in the formula. Which formula you have to use? This is the formula when the number, second formula you have to use. When the number of the data, the values of the data are small. In that case, you can get sigma xy minus sigma x into sigma y divided by square root of n into sigma x squared minus sigma x the whole squared into n into sigma y squared minus sigma y the whole square. That is a formula. Understood?
Yeah.
Now you substitute all the values here. What is sigma xy?
Sigma xy
Just see the board and tell.
597.
N is
9.
okay. Sigma x is
45.
sigma y
It's written there, uncle.
108. Yeah.
Yeah.
108. That's all. Numerator you got. Denominator is root of n
9,
again how
uncle.
much?
9.
Into sigma x squared of
285.
285
minus
minus
sigma x squared. So that's 45 square, uncle.
into again
Into 9, uncle. 9 sigma 1356.
very good.
1356, and then y squared, and then
Sigma y is how much?
sigma 108 square.
That's all. This is all. Now you'll have to just use your calculator. Open your calculator. Tell me all the numbers. you're getting the answer.
Nine into 597 is 5,373.
Okay.
Okay.
Minus
45 into 108. 45 into 108 is equal to 4,860.
okay. Now you minus this
You
also.
know,
5373 minus
3
minus
73
4860.
minus 4860. 513.
Okay. Okay, lower values you tell now. 9 into 285.
2,565.
Okay, 2565. 45 squared.
Minus 45. Minus 2025.
Okay, the other one now. 9 into
9
1356.
to 1356. 12,204.
Not 8 squared.
11,664.
Okay. 2565 minus 2025, how much?
Minus 2025. 540, uncle.
Very good.
1,000.
This one,
204 minus 664. Okay, 540, uncle.
very simple you are getting now.
Yeah.
513 divided by 540. Because 540 into 540 squared, if you
Is
take it out, then
540.
it becomes okay. Now tell me 513 by 540, how much?
3 by 40. 0.95.
That's all. So R equal to 0.95. That means very strong correlation between the two sets of data, X and Y. Okay. You understood now. Your textbook is
Yeah.
not giving all the steps and all, but all the steps are in calculator. Okay. You do your calculation properly, you will get this properly. That's all.
Okay.
So this one also I am putting in the WhatsApp. Everything depends on calculation, man.
Okay, uncle.
Everything depends on calculation. Okay, let us do one small sum. Example 9.5. This is also small sum only. We'll do even smaller sum. From the following data, calculate the correlation. This is the first formula. Okay. This is the
Uncle,
first formula.
good question. How do you find out which formula is which, uncle?
Because the data they are giving, no.
Okay.
Data they are giving sigma xy, then sigma x squared, then sigma y squared they are giving. The only formula that can use this
The
sigma
first formula.
xy divided by root of sigma x squared into root of sigma y squared. R is equal to. That's
So
the only
for
formula.
second formula, what type of question will they ask, uncle? They'll give tabular column data, something like that.
Once they give tabular column data, you have to usually use assumed mean method.
Okay. And then
Usually use assumed mean method. Unless you are very sure that when you look at the problem itself, you will get a mean as an integer. பார்த்தாலே மீன் வந்து மீன் is 15 டா அப்படின்னு உங்களுக்கு தெரியுதுன்னு வச்சுக்கோ. Then you go for the direct mean method formula. Sigma xy by sigma x squared root of sigma x squared into root of sigma y squared. Otherwise, never go for that direct mean method.
Okay.
Always go for assumed mean method. That means n into sigma dy dx minus sigma dx into sigma dy. That formula. Always go for that. By default, you assume that thing. Okay. But if they are not giving the table data, raw data they are not giving. If they are not giving two sets of data, but they are giving like this already. Okay. This will come in your 5 mark question, not 10 mark question. 10 mark question, you will get the full data. All the
Okay.
x, y values, everything in table you will get. But
Hmm.
in the smaller question, you will get like this.
Okay.
Okay. So immediately what they are given based on that, you just choose the formula, because you have no choice. Only 3 formulas are there.
Hmm.
So you have to choose only this formula here. R is equal to sigma xy. Okay. They are given. Now they are given this. What is sigma xy?
Sigma
What is
xy
sigma
is
x
120.
squared? 90. What is sigma y squared?
640.
640. They are given. Okay. So very simple. R is equal to sigma xy 120 divided by root of sigma x squared 90 into 640. Okay, that is equal to 120 divided by 9 into 64 into 100. Okay, that is equal to 120 divided by, this is 3 into 8 into 10. 3 into 8, 24 into 10, 240. 120 divided by 240. Cancel, cancel. 12 will go in 24, 2 times half. Answer is 0.5 plus 0.5. Very simple sum. You don't need to use calculator also for this sum. This fellow simply used 5,76,000, all that, and simply making the sum look more complex. Okay, it's not complex. 9 is 3 squared, 64 is 8 squared, 100 is 10 squared. Into. Once you remove the square, remove the square root, everything will go 3 into 8 into 10. That's all. 24 into 10, 240. Very simple sum. Let us finish early today. We'll do take some relaxing time.
Okay. Okay.
We did. Okay. Now we have to talk about rank correlation. Okay. Let us see what we will do. We will do just one problem in rank correlation. Afterwards, we can do. Monday morning. No, you're saying you're coming.
Yeah, Monday morning I can come on. Sir.
Okay,
Yeah,
Monday
I'm free.
morning you can come. Monday morning we can take up regular work. We'll just do one thing. Okay. What is this rank correlation, man? Rank correlation. You have seen beauty contest. You have not seen, huh? Some Christians are very holy. They will not see the beauty contest. Okay. At least you understand a beauty pageant.
Not
Okay.
really, uncle.
So there will be some judges sitting. No, at least 4 or 5 judges will be sitting, and all the ladies will do a catwalk and go. So for
Okay.
each of the girls who come and go, the 5 judges will put scores out of 10 or something. They'll put some scores. Okay. So what they're doing, they're actually putting ranking. Who's first, who's second, who's third, who's fourth, who's fifth, like that. No. So only ranking is being put there. You are not putting exact marks, okay, but you are putting ranks. That is why it is called rank correlation. So rank correlation is not an exact number based mathematical correlation in that sense. Okay, it is based on ranking. But this one, no, Pearson's coefficient is based on exact values. See, exact value. Height is actually 65, actually height is 66, 67. But in Spearman, you will not have the exact value 73, 71, 69 and all that. Instead of that, you will put, okay, 65, okay, put him first rank. 66, put him second rank. 67, all of that follows third rank. 68, fourth rank. 69, fifth rank. Sixth rank. 73, seventh rank. That's all. They'll only put rank data. Okay, that's all. Okay, now how you find out from rank data only? It's an important Spearman's rank correlation. Why you need rank correlation? Which situation? Like in a beauty contest, you can only do rank correlation. Okay. So rank correlation is much more simple formula than other things. Okay, where you will use, where you cannot measure quantitatively. Beauty cannot be measured quantitatively. How can you tell one girl is 752.3 units beautiful? Can you say anything like that? It is stupid, right? The other
No,
girl
uncle.
is 640.3 units centimeters beautiful. Nothing. Height and weight you can measure exactly with quantity. But beauty is a qualitative measure. Same way, moral values. This guy is 120 units honest. What is that? No, moral character, morality, character, intelligence, beauty. All this you can only give approximate values, and therefore you are using ranking. So there also you can still use correlation. Okay, you can still use correlation. One set of girls with another set of girls with another beauty context, like that. Or how one set of judges, one judge is giving the rankings, how does it correlate with another judge's ranking for the same set of girls? Like that you can find. Okay, which are the two judges who are having the very similar judgment or similar taste in beauty? Okay, like that you can find out. You can use Spearman's rank coefficient. Okay, Pearson's coefficient of correlation coefficient is mathematically accurate, and Spearman's rank coefficient is not mathematically accurate. It is for qualitative data, not for quantitative data. What is the formula? Here you don't use the value R. Instead, you use the symbol rho. Rho is a Greek symbol. Okay, so use the symbol, Greek symbol rho. Okay, you have to write it like that. This is rho. Okay, 1 minus 6 sigma d squared by n into n squared minus 1. Okay, that is a formula. You don't have to remember the second formula, because n into n squared minus 1 is n cubed minus 1. Okay, like that. Suppose 10 girls are ranked, then n is equal to 10. 10 into 10 squared minus 1, you will get like that. Okay, that means 10 into 100 minus 1, 10 into 99. That is 990 will get as denominator. Very simple formula. Okay, 1 minus 6 sigma d squared. What is this d squared? N we understand, rho we understand, 1 minus understand, 6 also understand. What is d? D is nothing but the difference of the ranks. Okay, to one judge is ranking Sushmita Sen as first, another fellow is ranking Sushmita Sen as third. Okay, the difference between the two ranks is 1 minus 3, that is minus 2. You understand? Rx, rank X minus rank Y. Judge X is doing a rank 1. Judge Y is giving the same person rank 3. So our rank 1, rank X minus rank Y. 1 minus 3, that is minus 2. Okay, that is the whole thing. That's sigma of that whole thing. Find this all the differences in ranks between the two judges. Okay, or between the two data, and or two paired data. And then, okay, you take the sigma of that. That's all. Put in the formula. Very simple. This one is much more simpler, very easier to calculate than the Spearman is easier to calculate than Pearson. Okay. Now, this also will have value between minus 1 and plus 1. Okay. This also, rho also will be like R also is less than or equal to 1, less than or equal to minus 1. What is the idea? If R equal to 0, there is no correlation at all. If R equal to 1, there is perfect positive correlation. R equal to minus 1, perfect negative correlation. Same way here also, rho is equal to 1, rho is equal to 0, or rho is equal to minus 1, same thing it means. Okay. Now, the problems are to be solved when two different kinds of data are to be given. Okay. When the ranks are given directly, when the ranks are not given, but other quantitative data is given, from which you have to convert that into ranks. Okay, you are not given the ranks, but you have to convert them into rank. We will do only example 9.6. Okay, we'll finish here today. Today Saturday, long day. Okay, Monday we'll do the other two, and we'll start the exercises. Okay. Example 9.6 only we'll do. Here ranks are directly given. So simple problem. Ranks are directly given. Let us do the simple problem. Okay. Example 9.6. Okay. Yeah, this is Spearman's coefficient, correlation coefficient, rank correlation coefficient. Okay. Now this is statistics. Rank is given. So rank of statistics, one column. Then rank of mathematics, another column. R, Y, R, X, like that you take. Okay. Because rank 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like that is given. Okay. The second one you should put, no, the pairing must be exact. You should not change it. Then everything is finished. 1, 4, 2, 5, then 3, 9, 7, 10, 6, and 8. That like second follower. The second judge is giving one rank. Okay. Now, what is D? D is Rx minus Ry. That's all. Very simple. That's all you have to calculate. Sigma D you have to calculate. Okay. 1 minus 1, 0. 2 minus 4, minus 2. 3 minus 2, plus 1. 4 minus 5, minus 1. 5 minus 3, plus 2. 6 minus 9, minus 3. 7 minus 7, 0. 8 minus 2, minus 2. 9 minus 6, plus 3. And then 10 minus 8 is plus 2. Calculate all the plus 1, 2, 3, 4. Okay, how much? 3 plus 2, 5. 5 plus 2, 7. 7 plus 1, 8. Okay. So plus 8 is coming. Now calculate all the minus. Minus, 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 minus. Minus 2, minus 3 is minus 5. Minus 6 again. Then again minus 6, minus 7. Minus 7. So that is equal to plus 1. Sigma D is equal to now plus 1. Oh, you don't have to calculate sigma D. You have to calculate sigma D squared. Okay. Sigma D squared. That only you'll have to calculate. Okay. Okay. Now, 0 into 0 is 0. 0 squared. Minus 2 squared is 4. 1 squared is 1. Minus 1 squared is also plus 1. 2 squared is 4. 3 squared is 9. 0 squared is 0. Minus 2 squared is 4. 9, 4. Okay. Sigma D squared. Now you'll have to find out. Okay. What is the formula for rho? 1 minus 6 into sigma D squared divided by n into n squared minus 1. Okay. What is n? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n is equal to 10 here. Okay. Now sigma D squared you have to find out. 4 plus 9, how much? 4 plus 9. James, 4 plus 9.
Yeah, uncle, I was on mute. 4 plus 9, no, uncle. 13, uncle.
13 plus 4.
13 plus 4, 13, 17.
17 plus 9.
26.
26 plus 4.
30.
Plus 1.
31.
Plus 1.
32.
Plus 4.
36.
Yeah, very good. You got what you wanted. Rho is equal to 1 minus 6 into 36 divided by n is 10. 10 into 10 squared minus 1. That is equal to 1 minus, how much is 36 into 6? Can you have calculator? 6 are 36. 3 6 are 18. 2 and 6. Okay. 2 and 6 by 10 into 10 squared is 100 minus 1. That is equal to 1 minus 216 by 10 into 99, 990. How much is 216 by 990? Can you calculate?
216 divided by 990, no, uncle. 0.218.
Very good, very good. 1 minus 0.218. Okay. So the other one is 1, so you can leave it off. Now 1 minus, how much this? 1 minus 0.218 is how much?
0.218. Okay, 0.782.
Very good. So rho is 0.782. So the rank coefficient of correlation is 0.782. That means overall there is a high level of correlation. If it is greater than 0.9, you can say that very high level of correlation is there. Here overall correlation is there. Okay. Very good. We will stop here. Okay. Today we will stop early, slightly early, only 10 minutes left. Okay. And let me post this first. Okay. And we will come back Monday morning. What time you want to come?
9:30, uncle.
Okay,
9:30 to 10:30.
9:30 to 10:30.
Yeah.
We will continue with our correlation coefficient.
Correlation. Yeah.
Okay. After that, we can do. After that, we can go to regression analysis once
Okay.
you master this. This is the most exciting topics. Okay. Once we finish all of this, you can go to what do you call operations management. The
Okay,
operations
uncle.
management, very interesting. Very interesting. When I did my bachelor's in architecture, for the final year, we had operations management. There it was called project management. There we did all the scheduling problems that you are now doing in your plus one itself. You guys are very, blessed guys, because you are doing in plus one what I did only in the final year of my college.
Okay.
Okay. So very good. Okay, man. Bye bye
Sure.
then. See you Monday morning.
Sure.
And what 10:30?
9:30, uncle.
9:30. 9:30.
Yeah,
Monday morning.
9:30.
Okay. Bye.
Bye, uncle. Thank you. Good night.
Good night. Have a nice weekend.